Maybe one day you'll get Ike's.
I know, what do you think?
Yeah.
There's too many options in Ike's. That's what scares me. Not scares me, but it's
Scares
just
you.
so overwhelming. There's so many options.
But they're good.
But I need more simplicity.
Alright, we're gonna wait like a minute or two for people to stroll on in. Tyler, Caesar, any other courses that you had this quarter at all, or no? He's the only one.
The ethics class I told you.
Oh yes, you did. Ah, man, I want to hear more about that. We'll talk about that
I
later.
like what I did.
Do y'all have any classes for summer session 2 at all, or no? Yeah, no.
My high school classes.
Wow, fake, dude, fake, big fan. And you? Which class did you take?
CSE 11.
Oh, 11. Okay.
And I forgot the other one.
Yeah, that's fine. That's cool. A lot of what you're going to be learning on 11 is kind of like the second half of this course, but you're going to get all that like in the first half of the course. A lot about like especially hash maps, which is basically dictionaries. It's the same thing, but in Java. So yeah, you're gonna have a fun time. You'll be fine. All right, so welcome everybody back to another wonderful iteration of CSE 8A, Intro to Programming Python. Today we're going to be going over dictionaries again and a little bit more of data processing, where we left off yesterday. Where now we're going to be likely working with a nested dictionary, so we can work to see how we can work with that data type, rather than a list of dictionaries. Okay. So a couple of announcements. PA6 is due tomorrow. I highly recommend y'all keep on working on that and submit that as soon as possible. The practice final has been released, and y'all should have gotten a message about that yesterday. And please work through those problems. We're going to be covering this kind of material over the next 2 days as well for the review for the final, as well as during labs and discussions. So please look over the practice final. A lot of the questions there are going to be similar, again, to what the final will look like. Okay. I also uploaded some grades on Canvas. Let me know if there's any issues with any of that, but I think I should have posted a couple of like lecture attendances recently. I think P5 was posted recently, and a couple of other things. But if you have any questions about grades, please let me know. All right. So today, we're looking at nested dictionaries, aka a dictionary of dictionaries, and some more data processing. Yesterday we were looking at some questions. We asked the question. We had Tyler here ask a question, and we walked through it. We're going to do something similar again with now nested dictionary. Nested dictionaries as our CSV file. Right. So the first practice problem that we're going to do is classifying length of words. So if y'all could open up your EdStem, and in your EdStem, head over to lecture 18, practice problem 1. Okay? And I'd like for you all to write this out yourselves over the next couple of minutes, and then ask questions as you go along if you have any questions. Okay? But basically, what we're doing is we have a function here called length of words that you'd have to write, and it takes a list of words, right? It takes a list of words of various lengths as input and returns a dictionary where the keys are the word lengths and the values are the list of words each corresponding length. All right? So what does that look like? Something like this. If you have your function called length of words and you pass in this list, cat, dog, and rat, then your resulting dictionary, the one that you return, should be a dictionary where the key is the length of a word, so in this case 3, and then the value will be a list of words that have that length in the string. So cat, dog, rat. Another thing is like here, 1, 2, and 3. We would have 2 keys. One key is 3 with the values of 1 and 2, and then another key of 5 with the value, which is a list that has 1 element, which is 3. Okay. So I'm gonna give you all just a couple of minutes to work on that. And then go ahead and ask questions as you go along if you have any questions. Okay. Oh, and one last thing to note. is that dictionaries, because they are not like positional, you don't index them, something like this means that they're like the same type of dictionary, that you get an equal thing. So having 3 with a list of 1, 2, and having 5 with a list with this 3 is the same thing as having 5 over here with a list of 3 and 3 with this list of 1 and 2. Does that make sense? Like it doesn't matter where the key value pair is in terms of the position of the dictionary, but because they don't use like specific positions, they are the same. Right. Hello, hello. Right now, Ella, we are just focusing on opening up EdStem, going to lecture 18 lesson, and then we're doing practice problem number 1. We just started. Okay? And what it is you have to write a function called length of words, right? It takes in a list of words, and what you have to give back is a dictionary, where the key is going to be a number, which is the length of a word, and then the value will be a list of all the words that have that length for the string. So if you have a list with 1, 2, and 3, then your resulting dictionary should be the number 3 as a key, and the value should be 1 and 2 as a list. Then a key of 5 with a value which is a list, which only has the string 3. Okay. Does that make sense of where they go and where they go where? Okay. I'll give you like a couple of minutes to work on that and ask questions as you work along so we can work through it here. Any questions so far, Ted? Oh, wait, right? Okay, we're going to get back to the lecture now. So all of you should have gotten a chance to try out and write out this function, right? So before we write out this function together, what I wanted to do is make some step-by-step instructions of what you need to do for this function to work. Okay? Basically, an outline. Let's make an outline of what this function should be doing. We don't have to use code at all. We can use simple language, right? To just write out what are the steps that we have to do for this function to work. Okay? So, what's the first step that we need to do for this function to work? Assume that we now started the function and we have a list of words. What should we do?
Create an empty dictionary.
Create an empty dictionary. Why is that?
Because you want the output to be a dictionary.
Because our output. Great. So the first thing we want to do is create an empty dictionary because we know that we want to return a dictionary. We don't start off with a dictionary. We don't pass in a dictionary, none of that. So what we know what we want to do is have something to return to the user, right? Something. And so step one is creating a dictionary because of our output. What about step two? What's the second thing we want to do? Tyler.
Iterate through your word list.
Iterate through word list. Why?
You need to like look at each word and see how long it is.
Okay. Because we need to see each word. I'm going to put each word and see how long it is. Right? So you know that you need to actually iterate through the word list, see every single word, because you need to see each and every single word and check to see how long that word is. Okay? What's our next step? What's the next thing we want to do? So now we have an empty dictionary because of our output. We're going to want to iterate through the word list. Let me actually write all this stuff down as we write down these steps. So step one was creating an empty dictionary. Let's call it result. Right? Empty dictionary with our curly braces. Right? Oh, so annoying. Oh my gosh, so oh my goodness. There we go. Empty dictionary because of our output. Right? Then we want to iterate through word list because we need each word's length. Right? So for word in word list. Right? So now we have step one and step two. Ella, do you know what we think we might want to do for the next step? So now we have an empty dictionary. We want to go through each one of the words in the word list. So we're doing 4 word and word list. Now what's the next step we want to do probably?
Is it like plus and equal sign and 1?
Plus
You have
equals
to check all of it.
plus equals 1 to check every single word.
Mm-hmm.
Okay, so we want to check every single word, that's for sure. And that's what we're doing with the for loop. The plus equals 1, a plus equals 1 is typically if we want to count up, right? We want to count stuff. Right now, for this function, instead of counting up, right? Instead of counting, like for example, how many times do we see a certain word? Instead of that, what we want to do is instead of counting to see how many words we see, instead what we want to do is check to see how long this word is, right? What's the length of the word? And then depending on how long that word is, we want to add, we could use a plus equals, right? We could use a plus equals. But what we want to do is add that word to a list where that list is the value of a key value pair, where the key is the length of the word, and the value is a list with one of those words there, right? Each and every word that's there. So instead of doing a plus equals, right now we need to know how long the word is, right? So how can we find out how long a certain word is?
Range and LEN.
Range and LEN. To do a range, it'll give you like a range of numbers from like 0 to the length of the number, or the length of the string. But you're very close. Instead of using the range of the length, what we want is just the length of the word. That's all we want, right? So word length, we're going to just do length of the word. Okay, that's what we want to do. That's our step 3. Step 3, find out length of the word, of each word, right? Find out length of word. And we want to know the length of the word because that's important for us in terms of where it's going to be in our resulting dictionary, right? So now we have our word length. Now we have our word length. What should we do now?
See if or check if the length is in the result key, or is a key in result.
If the key is in result, right? So if the word length that you have now, right, in, should I do result? Or is it result.keys? How should I do that? Or result.values?
You could just do result.
Just result. Just result is fine. Doing this, if word length in result, is the same thing as doing if word length in result.keys. We're just looking at the keys of the dictionary. That's it. Okay? So if the word length is actually inside of our result, what do we want to do?
Result. Hard brackets. Length.
Or instead of code, what do we want to do instead of code?
Add the word to that specific key.
Add the word to that specific key. That key is like, for example, 3. That key has a list. And we want to add the word that we're looking at to this list that currently exists, right? So what we can do is result, bracket word length, right? Because the word length is found as a key. Dot, append, word, right? We can add a word to that list. Similarly, like Ella was letting us know, we could also do the following. Plus equals, and then the list item with word. Either one of these two would work, okay? Either one of these two would work. Let's stick with append for now, just so we can work with list methods, okay? So find out length of each word. That's our step 4. Sorry, step 3. Step 4 was check to see if length is a key in dictionary, okay? In resulting dictionary. Then step 5 was if it's in the dictionary, then we append to existing list, right? What about step 6? Ella. Since we're checking now, we have an empty dictionary, right? We're going through each and every single word in the list of words, right? We check to see what the length is of that word. We have that. And if that word length is in the result, we're going to add that word to that existing list, right? What if we don't see that existing word length? What if we don't see that word length in the resulting dictionary? What should we do now? So we have our dictionary, where the dictionary will be, the key is the length of the words, and the value will be a list of words, right? If we did find that word length, So for example, if we have 1, 2, and 3 here, and then we add another word of cat, for example, C-A-T. Cat has a length of 3, and it checks to see if 3 is in this dictionary. Is 3 in this dictionary? Yes, it's right here. So what we would do is just append, right now, on line 19, we append that word, cat, to this list. 1, 2, and then cat. Right? But what if we want to add another word here called 4? Right? So 4 is a length of how many letters in the word 4?
3.
F-O-U-N-R. 4. Right? So with 4, has a length of 4. Is 4 currently in the keys of this dictionary? No. So what do we want to do? Do we want to add it?
Subtract 1.
Subtract 1? No, because if we subtract 1, right? If we subtract 1, then what we're doing is, instead of adding the word 4, we're changing the word 4 to be something else, which we don't want to do. We want to keep the data intact, right? So what we can do, though, is since the number 4 is not a key yet, we can add that key, right? We can add that key to this dictionary. And the way that we can add that key to this dictionary is that we use the dictionary name, result, then we put the length of that word, because we know that the length is what we're using as our key, right? And we're going to set it to a certain value, okay? And that value should be a list. We know it has to be a list. And we can start off with the word that we're looking at, which is word. Okay? Just word. Right? So now what we're doing is anytime we find the existing word length, we can just add that word to that dictionary list. Right? That list that lives inside the dictionary. But if we don't have a word length in that dictionary, we just want to add it. So we want to add it to the dictionary. Are we done here?
We need to return the result.
We need to return the result. Is here fine?
Outside of the for loop.
Oof, outside the for loop. Remember, if the return is inside of the for loop, it will not necessarily end the for loop, right? If you're in the for loop and you have a return, it's going to immediately leave the function. It doesn't matter if it's in the first iteration or the millionth iteration of that for loop, it'll leave, right? Unless you have it outside the for loop. Great. Are we done now?
You can call the function.
We can call the function, right? But are we done with the function itself?
Yes.
Yes, I think so, probably. So let's try something out. Names. We're gonna have a list of names here. My name is Ismail. Tyler, what's your name?
Tyler.
Tyler, right. We have Tyler here, we have Caesar. We have Ella. We have Chowhui. We have Kevin. And we have Audrey. Hey. Almost.
Camera.
I know. Okay, so now we have a list of names. This is everyone's name that is currently inside of this room. Okay? What's the length of this name?
6.
6. What's the length of this name?
5.
5. What's the length of this name?
5.
5. So both of these should probably be in the list together, right? In the dictionary. This one by itself so far. What's the length of this name? 4. Is there a 4 so far? Or is this the first 4 we see?
First 4.
Since it's the first 4, we'll add Ella's name, where the key is 4, and the list will now be just Ella's name for now. What about this name, Chowhui?
7.
7 by himself, right? What about this name?
5.
5. Have we seen 5 before? Yeah? So Kevin will be alongside Tyler and Caesar. And then Audria.
6.
6. Have we seen 6 before? Yes. With which name?
Ismail.
All right. Okay. So we have our list of names. What we can do is print out the length of words and we pass in names, right? Let's see what this gives us. Let's run that. All right. So now we have our dictionary, where 6 is the key, and the value is the list of names, right, that have that length in their string, 6. Ismail and Audrey both have 6 letters in their name. Tyler, Caesar, and Kevin all have 5 letters in their name. Ella has 4 letters in her name, and Chao Hui has 7 letters in his name, right? Does that make sense on how we got there? Yes, no, yes, no. Yes? Okay, awesome. All right. That about does it for that first practice problem. Let's look at the second practice problem. Distribution of majors. This one we'll all work on together, okay, instead of going out and then coming back in. But for practice problem 2, we have a function name that we want to make of distribution majors, okay? Distribution majors takes in a list of majors, so a list of strings that denotes the majors of students. Then it's going to return a dictionary of majors as its keys and the number of students as its values, okay? Very similar to word counter, this is now going to be a major counter, right? We're going to count up the amount of majors. Then we find the answer to the question, which major is the most popular, okay? We'll do that afterwards. We'll do that afterwards. But first what we want to do is create this function, right? Distribution of majors. We take in a list of majors. And what we want to do is return a dictionary where the majors is the key and the number is the value. So all majors, let's look at this. So we need a list. And we're going to get a list of majors here in this room so we can see what will be outputted in this dictionary. So, Audrey, what's your major? CS.
Education.
CS education. You're in the computer science track, right? So I'm gonna put you for CSE for now. Okay, just CSE. Kevin, how about you? What major are you?
CS.
CS. Okay, we'll stick with CS then. That's CSE. All right, CS. We have 2 CS majors. Chao Hui, what major are you?
CS.
CS. I'm starting to see a pattern here. Weird how all these staff members in a computer science class are all CS majors. Anyways, Tyler, what major are you? NA?
Yeah,
NA. Not available. Tyler's in high school. Soon you'll pick your major. Hopefully it's computer science, right? No pressure, of course. Caesar, what's your major?
Applied mathematics.
Applied math. Not CS, wow. Applied math, right? Great. Ella, what's your major?
Psychology.
Psychology. Great. And then lastly, Ismail. What's Ismail's major? Shocker.
You're done.
It's CS. No, I'm not done yet. I'm not done yet. But we have our list now. We have our list of majors, right? We have CS, 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 NA, Applied Math, Psychology, and CS again. Okay? So the dictionary that we want to create should be the following. Expected dictionary, right? We're going to make our dictionary here. Should be, CS is how many times?
4.
4. NA is how many times?
1.
1. Applied math is how many times?
1.
1. And then psychology is how many times?
1.
1. Thank you, Caesar, for that. Okay, cool. So, now we know what we want it to look like. How can we get to this dictionary?
You first need an empty result dictionary.
First, we need an empty result dictionary. You read my mind. I love calling it results inside of function. We can name it anything we want, right? But I'm just going to leave it as results for now. Okay? Dictionary. Now what do we want to do?
Cycle through each major in the input list.
Cycle through each major in the input list. So we would use like a for major in list of majors, right? So now what we're going to do is look at the actual string itself, not the index or the range, right? But the actual major itself. Then for each major, what do we want to do?
You want to check if it's in result.
We want to check to see if this major currently lives within the dictionary called result. So if major in result, what should we do?
Result major plus equals 1.
Yes, result major plus equals 1. Now what Ella was telling us last time, it applies here now. Because now we are counting up just the amount of times we see each one of these majors. CS was, like when we first start reading this list, we have nothing. Is CS in the major? No? Okay, now we're going to make it 1. Is CS in the major? Yes. So we're going to add 1 to that. So now it's 2. Is CS in that major? Yes, it is. So we're just going to add 1. That's the plus equals 1. We're just adding 1 to the many times that we've seen it. Now, Ella, if the major is in the result, we check to see where it is, what that major is, right? Result at major, and we do plus equals 1. If we don't see that major in the result, what do we want to do now?
Result major equals 1.
Yes, exactly. Result of major is equal to 1. And the reason for that is, since you've never seen this before, majors and result, major's never been a result, but you're seeing it now for the first time, you're going to add major as a key, and the value is going to be, this is the first time I see it, so I'm making it 1. Okay? First time I'm seeing it, making it 1. Are we done?
I'll return.
Ah, we got a return right here.
Outside the for loop.
Outside the for loop. Return. What do we return? Major?
Result.
Result. Okay. Now we return the result. Let's see if we get what we were looking for. Print distribution majors of all majors in this room. We run that. CS is 4. NA is 1. Applied math is 1. And psychology is 1. We did it. This works. What if someone were to walk in and they say, I'm also majoring in psychology? Add them to the list. What should that resulting dictionary look like now?
So,
2 for psychology.
2 for psychology, and that's it? So it would just be psychology 2 and nothing else in the dictionary?
No, it would be the other stuff too.
It'd be all the other stuff the same, and we would just add 1 to that psychology, so psychology should be 2. We run that, and boom, now it's 2. Okay? Any questions on how we got here? No? Yes, no, yes, no? All right, so we get distribution of all majors. Right? Now we're going to save that into a variable. And what we want to do now is, given this dictionary, right? So printing distribution of all majors, right? We have this dictionary that we have. CS4, NA1, Applied Math 1, Psychology 2. We'll actually remove psychology, right? Because we don't have another person that majored in psychology in the room yet. With this distribution of all majors, I want to make a new function now. And this new function is going to calculate the most popular major. So right now, what's the most popular major?
CS.
CS, right? So what I want to do is input this dictionary into a function, and I want to return the key, the major, which has the largest value. In this case, 4, right? So let's make a new one. Def get popular major, okay? And then it's going to be major dict majors, right? A dictionary of majors. What should we do now? We now have this function, get popular majors. Okay. And if we do this print get popular major, and we pass in the distribution of all majors, if we were to print this, we expect CS, right? We're hoping to get CS out of this. We don't have to print out how many there are. We just have to print out that that is the most popular. That's all we have to print out. So how can we get the most popular major? What are some things that we have to consider? What do we have to return?
A string.
A string? And what should that string be?
CS.
CS, right, in that case. But like, in theory, what should it be? It should be
Most popular major.
the most popular major, right? That's what the string should be. So I'm going to create an empty string of most popular major. And I'm just going to make it empty. And say, the most popular major, I don't know what it is yet. But I want to return a string. And if there is no most popular major, like if there's no majors, I'm just going to put empty. Okay, that's it. Now, what should we do?
I think you should have a variable for like the biggest number you've seen so far.
Biggest number you've seen so far. Largest number so far. And what should I make that variable equal to?
Anything 0 or less than 0.
0 or less than 0, we can start off with 0, right? Because given this dictionary, we can assume you'll always get a positive number. You'll never have a 0, right? A positive whole integer that's not 0. Because when we first create this list, we never start at 0. We always start with 1, right? So anything greater than 0, that will be the next greatest number, okay? So the largest number so far is 0, and the most popular major is nothing. What should we do now?
I think iterate through your majors.
You have to iterate through your majors, right? The majors or the values? Or both?
Both.
Both. How can we iterate through both?
Or, and then you have two variables.
K and value, sure, K and V.
In dict majors, do you need the dot item?
You do. If you want to do it like this, you need for K and V in dict major dot items. This will give you both the key and the value immediately with you, okay? We could rename these to be, instead of K, we call it major. And then instead of V, it could be total, right? Total. That way we know what these names mean. For major and total in dict majors dot items. Because this is going to be the major, and this is going to be the total of students in that major, right? We could do it this way, right? And let's just work it out like that, doing it this way. So for major, total in dict majors dot items. What should we do now? Ella, for example. We're here. Our most popular major is nothing so far. Our largest number so far is 0. And we're looking at the major and the total. So like the first time we go into dict majors dot items, the first thing that we get, major will be CS and total will be 4. What do we want to do?
Count the numbers.
Count the numbers. So we have the count here, which is 4. We have the total number. But what we want to do is check to see if this number, is it less than or greater than the largest number we've seen so far. Okay?
The if statement.
An if statement, great. So if the total, right, if our total is greater than our largest number so far, right? Because we're looking for the most popular major. So it needs to be the largest number out there. If the total that we have is greater than the largest number so far, then we know we have a new most popular major so far. Therefore, what can we do?
Most popular major equals major.
Right? Our most popular major is now the major that we're currently looking at. Are we done?
And the largest number so far equals total.
The largest number so far is equal to total. You have to update your largest number so far every time. Okay, every time you see a new large number, make that your new largest number. Right? If you have a total that's larger than your current largest number so far. Are we done?
Return, or outside of for loop.
Ah, thank you. Return.
Most popular major.
Most popular major. Okay. So the way we have it now is we have our most popular major, which is nothing. We have our largest number so far, which is 0, right? Any key value that we find should be larger than 0. So for major total in dictionary, dict majors.items. So now major will be the string, which is the key, and total will be the integer, which is the value. If the total that you're looking at is larger than your largest number so far, you just update your stuff. You do that for all the dictionary keys and values, and then you return your most popular major. Okay. Let's run that. Ta-da! CS. It's kind of hard to see it well. Let me see. Print distribution of all majors. Right. We know it's CS because CS has 4. Right. But CS was the first one. Let's make it the last one that gets updated. So let's put psychology. Ecology. Right. We're going to add that a couple times. Boom, 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 boom. Okay. So now the most popular major should be psychology. Let's run it. Boom, psychology. That's our new biggest one. It's not just like the first thing you see. The first thing we saw was CS last time. And then it never got updated again. But now it first gets updated with CS. It doesn't get updated for NA. It doesn't get updated for Apply Math. But it does get updated for psychology because psychology is larger. And we're good with psychology. Does that make sense for everybody? Yep. Cool. Great. Let me remove all of that. Cool. All right. So that's practice problem number 2. Any questions on this sort of like dictionary creation, iterating through a dictionary, all that stuff? Oh, I did say we could do this same function of get popular major, but without using the dot items. We could do the same thing without using dot items. Okay? And let me show you what that would look like. Instead of using dot items, it would be something like this for major and dict majors, right? Because this will get you the key, which is the major itself. Then you'd have to say total is equal to dict majors at position major, right? Just to see what that value is. And now this code works exactly the same. Let's run it so we can see it. CS. We still get the right answer. Okay? Because now, instead of getting major and total using dict majors.items, you could just iterate through the keys of dict majors and then get the total dict majors at position major. Okay? Cool. Now, practicing with CSV files. We were doing this yesterday, right? We had people asking questions, and we got to see that information. Great stuff. Now, as promised, instead of using UCSD data, we're going to be using UC data. All UC system schools. Okay? All the UC system schools. We have some data sets of those demographics. Okay? Data sets of those demographics. Let's look at what they look like. UC all. Let's just look at UC all. How many columns do we have in the CSV?
3.
3, right? Because we have one thing, a comma, a second thing, a comma, a third thing, and nothing else. 3. 3 columns, right? First column is our institution. UC Berkeley, UC Davis, UC Irvine, UC San Diego, UC Merced, all these different institutions in the UC system. Our second column is the ethnicity of students, right? International, domestic unknown, white Asian, Native Hawaiian / Pacific Islander, Hispanic / Latino, American Indian, African American. Okay? These are our ethnicities that we have. And then lastly, we have students. How many students of that ethnicity at that institution exist? So how many African American students are at UC Berkeley?
1,324.
1,324. Okay. Right there. Okay. This data is for 2023, right? We can get some updated information later on. But let's work with this data set for 2023. So, we have a sample question here. Using the UC CSE demographics, UC CSE and UC all look very similar. Let's look at UC CSE. It's the same stuff, right? But now we just look at computer science department. That's what we're looking at, the computer science and engineering department. Okay? Using the UC CSE demographics.csv dataset, which returns a nested dictionary. Okay, we're not working with a list of dictionaries now. It is a nested dictionary. Which UC campus has the highest representation for Native Hawaiian / Pacific Islander students? Okay? Which one has the highest representation for that student population? Right? So let's just print out UC CSE to see what it looks like. Run that. We have a dictionary, right? A dictionary with a key, and the value is another dictionary, where those keys are the ethnicities, and the values will be the totals, okay? The total students for that dictionary. Yes, question?
Is representation like the percentage of those students on campus, or is it just a number?
That's a great question. How are we considering representation? We can try to do it one of two ways, right? So way number one, right? Representation number one. What's one way that we can look at representation?
A percentage.
A percentage? What's that percentage?
Percentage of Hawaiian and Pacific Islander students on campus.
Native Hawaiian / Pacific Islander students on campus. And how do you find this percentage?
Finding the amount of those students over the amount of the total students.
You get the number of Native Hawaiian / Pacific Islander students and divide that by the number of total students. Total students. Cool. We can do that. That's one way of looking at representation. You said that there was another way of looking at representation? What's the other way?
Just the number of those students on campus?
Just the total number. Number of Native Hawaiian / Pacific Islander students. Right? On campus. Right? So, for example, if you have a UC campus that has 1 billion students, right? But you have 1 million Native Hawaiian or Pacific Islander students, a lot of Native Hawaiian Pacific Islander students. It's still like a low percentage, but it is a high number of students that you're getting, right? Versus if you have a UC class, a UC system that has 100 students and, I don't know, 100 are all Native Hawaiian Pacific Islander students, then you have a very high percentage, but a very low number compared to that other institution. For the purposes of this question, let's focus on the top one. Okay? The reason for that is because at the end of the day, we're going to get that answer, right? The number of Native Hawaiian Pacific Islander students on campus. But we're going to use, we're going to use that number for this formula anyways. Okay? But that's a great question. All right. Oh, you know what? We can make our function return both of those numbers. Let's make it so that we return both.
Okay.
Both of those numbers. We'll keep track of both. All right? So, we have our nested dictionary. All right? Nested dictionary. And what we want to do is check to see which one has the highest percentage of Native Hawaiian Pacific Islander students and which one has the highest number just in general of Native Hawaiian Pacific Islander students. We'll keep track of two different things. So what do we want to do with our data? What do we want to do? What should we do? How can we answer this question? If we want, we can just focus on just the top one to make it simpler. Then I'll show you an easy way to keep track of that second one too. Let's just focus on the top one. How do we get the UC campus that has the highest percentage of Native Hawaiian Pacific Islander students on their campus for the CSE department?
I think iterate through your CSV file.
We have to iterate through our CSV file. The file itself, or the nested dictionary that we get from the CSV file?
The dictionary.
The dictionary. You could, in theory, iterate through the CSV file itself, but then you're going to get a bunch of rows of like text, and that's what CSE AACSB does, right? So I'll just give you a quick peek into what that looks like, right? Get UC data. Get UC data does all of that. All of this is doing reading the actual CSV file and saving that information for a nested dictionary. Should we edit this CSE AACSB file? No! Do not edit it. We are simply using that function. Okay? So you're saying iterate through the nested dictionary. Okay, cool. What's a good name for when we iterate through this nested dictionary? What's a good name?
Key.
Key. Key is great. In UC CSE data. Right? What's going to happen when I print key? What should we be printing out right now?
Each UC.
Each UC school. Right? Let's run that. Boom. UC Berkeley, UC Davis, UC Irvine, UCLA, UC Riverside, UC San Diego, UC Santa Barbara, and UC Santa Cruz. Oh, we don't even have UC Merced here. And I think the reason for that is because UC Merced, I don't know if they have a dedicated computer science department, at least at the time of us getting this data. Interesting to note. What if we were to do the same thing for UC? Oh, let's run that. Just want to make sure that Merced is there. Yeah, Merced is there. Cool. Okay, cool. Just making sure. Right. So we're looking at just the CSE department for now. Okay, CSE. Now we have our keys of our CSE data. What should we do now? For now, let's just print out so we know what we're working with. UC CSE data at that key. Okay? And then let's just break. So we only see one. Let's just see one of these things, what it looks like. We have our key is UC Berkeley. And then our value is a dictionary again with all this information. What is it that we want to do?
Add another for loop.
Have another for loop? Absolutely, we can use another for loop. Okay. For, what do we want to name this?
Ethnicity.
Ethnicity. In.
Maybe rename key to like university.
Okay, let's do that. Let's call it uni.
And then uni.
Uni. Like that?
Yeah.
Yes. Great. Because uni will be the dictionary, right, of all the ethnicities and the students. Ethnicity is just going to give us the keys of uni, right, which is all of those ethnicities. Maybe instead of uni, we'll call it uni data. Yeah, that's a better name. Is that going to work?
Like there won't be any run errors, but it won't like do what we want.
Are we sure there's not going to be any run errors? Let's just print out ethnicity. Oh, snap! We're getting letters. Instead of uni data, they should have stayed as uni. But what we want is the UC CSE data at that, UCI, no, uni. What we want to use is use the uni key to access that data, and this is going to give us the dictionary. So now we should be getting all the ethnicities. Let's try that out. Boom. That works now. Okay? Great. Now what should we do? Remember, we're looking for the university with the highest percentage of Native Hawaiian Pacific Islander students on campus.
Find the total amount of students on campus.
Total amount of students on campus. How do we do that?
You have to create like a variable that starts counting how many students you go through.
That counts all the students, right? So we call it like total on campus.
Yeah.
I'm going to put it right here. I'm going to start off with 0. And this is just going to count up all the students, right? So regardless of what ethnicity it is, we want to do is total on campus plus equals UC CSC data at position uni at position ethnicity. This will give us the amount of students at that university for that ethnic group. And you're going to get the total on campus. Awesome. Are we done? What should we also do?
Create a second variable for the ethnic group you want to compare it to.
Okay. What's the ethnic group that we want to compare to? Native Hawaiian Pacific Islander? Right? And then we get like Native Hawaiian Pacific Islander students. How do we get that to update? How do we get that key? Or sorry, that amount of students?
You-
You
Let's
can
do,
do
we'll do both. We'll do both. What's the first one?
create an if statement
You can create an if statement, right? Where should I put that if statement?
inside the folder.
Inside the for loop. If
Ethnicity equals, and I'm not sure what,
it's that one, yeah. If that, then what should we do?
set,
Native Hawaiian Pacific Islander students, I would say on campus, is equal to what?
UC CSE data uni
Okay. We could do that, right? So we can try and get the total amount of students that are that ethnicity. Should we plus equals or equals?
equals.
Equals. Right? Now what should we do? We should probably calculate for this percentage. right? How do we calculate for that percentage?
You divide.
Divide. Number of Native Hawaiian Pacific Islander students divided by the number of total students, right? That's what we want to do. Great. How do we do that?
Total on, or I guess we can.
So in case like average on campus, we're gonna make that equal to total. Sorry, what was it again?
Total on campus. Or other. I'm sorry.
Aha, yes. So NHPI students on campus.
Divided by total on campus.
Total on campus. Great.
Multiply it all by 100.
Multiply all that by 100. We for sure can do that. There you go. Are we done?
Return the average.
Return the average.
Oh, yeah. Print the average.
We what? Append that average?
Print.
Print the average. Are we done? Remember, what we want is the campus with the highest percentage of representation. So how do we get that? Hint, hint. It's something very similar to what we did over here. Something very similar to what we did over here. Right now, we go through each campus, we get its total students, we get the total Native Hawaiian Pacific Islander students, then we get the average of that on the campus, and that's all we're doing so far. Are we done? No. You're not checking to see if it's the highest average. You're not checking to see which campus you're looking at. So we need two more things. So what we can do is before we get into that for loop, we can say highest rep campus, and we're going to make that an empty string. We're going to say the campus with the highest representation is some campus. We don't know what it's going to be, but we have an empty string. Then we can also say highest rep. Highest representation so far is 0%. Let's assume 0% is the highest representation that we've looked at so far. Right? That's it. Great. Now what do we do?
If statements.
If statements. Where?
Under the average.
Under the average. Here?
Or inside the for loop.
Inside the for loop. If
Average on campus is greater than highest rep.
what should we do?
Highest rep equals average on campus.
Yes. Our new highest representation is this average on campus that we have. Then
Highest rep campus equals uni.
equals uni. Yes, uni. Uni will be that university. Right? Okay. Are we done? No? What should we do, Tyler?
Return the university.
Return. Why would we return?
Or not return, print.
Aha, yes. Right now we're just printing because we're not inside of a function yet. What should we print?
Your university.
Uni, like that?
Yeah.
Highest rep campus.
Highest rep
Oh, yeah.
campus, right? Highest rep campus. What we want is just the highest representation campus. Rep campus, right? Has the highest representation at, and then highest rep. Just so we can see what the representation is. Let's run that. Ta-da! UC Davis, geez, UC Davis has the highest representation at 0.405%. Pretty low. Pretty low, UC system, pretty low. Okay? Geez, that's really low. I did not know that until we did this right now. Wow. That's pretty bad. Not good. Oh, geez. I want to see if that's the same case for all students. Let me run that. UC Merced. Oh, you see CSE data here. Whoops. There we go. Also this one. Also this one. Let's run that. You see Dave is still with the highest percentage for Native Hawaiian Pacific Islander students with a whopping 0.32%. 0.32%, not even like a 1%. Like that's maybe not great, you know? Again, I don't know if that's great or not, right? We have to check to see what the actual representation is of Native Hawaiian Pacific Islander population is in general for the whole entire United States, right? If the whole entire United States, of the whole entire population of the US, if the whole population was 1% Native Hawaiian Pacific Islander, I mean, I'd argue we're still pretty bad, right? Even if it was just 1%. Because this is still less than half of the actual representation of people in the US for Native Hawaiian Pacific Islanders. Not great, okay? Not great. But anyways, I digress. We now answered the question. Okay. We answered this question. The percent of Native Hawaiian Pacific Islander students on campus, which one was the highest one, right? We found the highest one. I'm going to tweak this code just a little bit to get the same exact answer, just with less lines of code, okay? Using some dictionary methods that we've learned before. There's a kid that's trying to look in. So, yeah. Anyways. Okay. So, what can we do instead of doing all this? One thing that we can do to make this a lot easier for ourselves is we can say, instead of total on campus is at 0, then we iterate through all the ethnicities and then look for all the students in those ethnicities, all that stuff. What we could do is instead of that, because what's total going to do? Total's just going to go through every single ethnicity and add up all those students. Is there a way that we can get all of those values together, all in one go? Yes?
Is there like a sum method or something?
There's a sum, right? But sum needs to sum up a bunch of things together, a bunch of, like a list of integers or floats and stuff. What are we going to put in there into that sum?
Your values.
How do I get my values?
UC CSE data uni dot values.
Yes. UC CSE data uni dot values is going to go to the CSE data for that UC at that specific university, and it's going to get you that whole dictionary. But then it's just going to give you all the values for that dictionary. All the values for that dictionary. Which means we don't have to go through all these ethnicities, right? All of them at the same, and we don't have to iterate through every single one. Another thing that we can do with dictionaries is we don't have to go through every single position in the dictionary to look for Native Hawaiian Pacific Islanders. How can we get Native Hawaiian Pacific Islander students immediately in one line? The amount of students.
You can just use the key.
You could just use the key. So we would do Native Hawaiian Pacific Islander students on campus is equal to what?
UC CSE data uni and then like the Hawaiian Pacific Islander.
Native Hawaiian Pacific Islander. You can use the key immediately. You don't have to iterate through all the ethnicities and find it and then save that value for later. You can just get it right away. Okay? You can get it right away. So now when we run it, it still works. Right? UC Davis has the highest representation at 0.4051%. We did it. Same exact result, but with a different way of doing it. Using our sum function. Using our dot values method. Right? Or not having to iterate through all the ethnicities, just the exact one that you're looking for. Right? And then you can get your average on campus. And then if all that still stays the same. Fantastic. What if we wanted to do it for African American students? What should we have to change? Instead of Native Hawaiian Pacific Islander students, now we want to do it for African American students. How can we change our code? Let's, thank you.
We changed Native Hawaiian Pacific Islander to African American.
Change this to African American. Are we done? Yeah, we run it. Boom! UC Riverside. UC Riverside has the highest representation for African American computer science students across the UC system at 3.28%. Okay, 3.28%. Now, how can we do this in a function so that we can just, instead of changing African American, Native Hawaiian Pacific Islander, like hard coding it every single time, one thing we can do is have a function. So I'll get representation, or get ethnic representation. You see, right? You pass in your data, and you pass in the ethnicity that you're interested in. And instead of here African American, this would be ethnicity. Instead of NHPI, it'd be ethnic students on campus, right? And I think that about does it. This would be it.
Wouldn't you have to change your data?
Oh yeah, you would. Sorry, thank you. Yeah, instead of that, instead of CSE data, you do my data, my data, my data. Great. And the last thing we would have to do is also return. We're going to return this. We're going to return string. Boom. We're just going to return a sentence, right? So now we could print get ethnic representation UC with UC. Let's do all data now. Ah, that's so annoying. And then we can, instead of ethnicity, we can put, what ethnicity do we want to look at? There's a bunch that we can check. Which one do you want to check? Any of them.
International.
International. Which UC has the highest percentage of international students for their CS department is UC Davis. Okay? UC Davis has the highest representation for that. Or has the highest representation, I'm going to put here, for, and I'm going to put ethnicity. Run that now. So UC Davis has the highest representation for international at 13%. Okay. Well, what if it was just the CS students? What I would do is just do this. UC CSE. Now UC Berkeley. UC Berkeley has the highest representation in the computer science department for international students at 20%. Okay. Does that make sense on how we got there? Yeah? And this is how we can use nested dictionaries, okay? I wanted to show you the nested dictionary way because there's two ways of doing it, right? The first way was the first way we did it, right? We would go step by step, go through each ethnicity, each UC, to get our information. But we could do it much more condensed with a nested dictionary using the sum of my values, right? To get all the totals of students of that university. Then you get the specific ethnicity that you're looking for, right? With my data uni at ethnicity. So you don't have to iterate through the whole dictionary to find that key. You already have your key, what you're looking for, and you can immediately get it and store it without having to iterate through all the ethnicities. Then you can do all your calculations to get your answer. Any questions on how we got here? Oh, we said, sorry, I said I was going to do both of these versions, right? Both of these versions. How can we do both of these versions now? So now instead of highest representation, we could also do highest enrollment, right? Enrollment is just the total number. Not a percentage, but just a total number, right? Highest enrollment will be 0. And then highest enrollment campus is an empty string. We can do the same thing here, right? But now, if ethnic students on campus is greater than the highest enrollment, then our highest enrollment is equal to the ethnic students on campus, and then highest enrollment campus is equal to the uni that you're looking at, the university. And now you can return, you know what I'm going to do? I'm going to do the following. I'm going to make it a list now. Oh no! Thank you. There we go. There's going to be a list now of 2 different strings. Where now, the second thing we're going to have is stir highest enrollment campus has the highest enrollment for that ethnicity at highest enrollment. Okay. Run that. Okay. So now what we're returning is a list with 2 strings. Right? I'm going to call it my values just to see that we got something here, right? And so we can print out my values at position 0, and then print my values at position 1. Okay? So this is going to give us the highest representation and the highest enrollment at the same time. So UC Berkeley has the highest representation and enrollment for international students in the CSE department, with 20% of its CS students being international, and the total number is 639 students. It's a lot of students. Okay. What about all students? UC Davis. UC Davis has has a higher representation for international students in like the entire institution, with 13% and with the highest enrollment of international. What about Hispanic, Latino, right? Run that. UC Merced has the highest representation at 55%. Incredible. Wow, UC Merced. Doing the work. And then UC Riverside actually has the highest enrollment in general for all of the UC institution. But what about for CSE's department? UC Merced does not have a CS department, unfortunately. So now UC Riverside has the highest representation for Hispanic Latin students at 17%. And UC Irvine has the highest enrollment at 264 students in their CS department. Does that make sense of what we're doing now? How we can create our function to get a bunch of different information? Yeah? Okay, great. Any questions on this at all? We are now at like 2 minutes before the end of class. No? All right, great. What am I going to do? Dang it. Okay. There was one last question that I wanted to do on CSV. Is it okay if I do the whole question really fast for you? Okay. For a university, there is a title that it can get called Hispanic Serving Institution. A Hispanic Serving Institution, you get that label if your total student population in your university is 25% or higher of Latin American students. That's how you get the tag HSI, Hispanic Serving Institution, right? So what we can do is create a very similar function, def get HSI unis, right, with my data. So you're just going to get your list of data, then you get your HSIs. HSI unis is going to be a list. And for my data, for uni in my data, you can do something very similar to what we did before, where total students is equal to the sum of my data at the university dot values, right? So you get all the students. Then you get your Hispanic students, so your Latin students, is equal to my data at the university with the it's Hispanic dot slash Latino, Latina. Okay, that's how you get your Latin students. Then you get your average. Average students is equal to 100 times Latin students divided by total students, right? We just get the average, what we've been doing before. But now we have to check if average students on campus is greater than or equal to 25%. Then we're going to add HSI unis. We're going to append, what should we append here? Well, one is the list of universities. Uni, precisely. So now we can return HSI unis. So now you can get, whoops, there we go. Print get HSI unis with UC all data, right? With UC all data. So now we can see which of the UCs, oh dang, UC all data, average on campus.
It's average students.
Oh geez, average students, thank you very much. Thank you very much, did not see that. Now we get a list of Hispanic serving institutions in the UC system, which are UC Irvine, UC Merced, UC Riverside, UC Santa Barbara, and UC Santa Cruz. That's for UC all. If we do CSE, we can check to see if this Hispanic serving institution label would still hold just in the CS department. Let's see if it does. Oof. None of them. None of them. Okay. None of the UC systems have 25% or more Latin American students in their CS department.